side of yesterday's homework, just the bottom chunk. You just did the front yesterday, right? Okay, so first thing, switch your calculator into radian mode. Okay, so what you're going to notice is that whenever you have, it should tell you which one to do. So if I'm down here, how do I cancel out a cotan to know what x is? I have to do an inverse tan. Well, really I need to do an inverse cotan, right? But then when I try to type cotan and inverse cotan cross out, x equals. But then if I want to type this into the calculator, I have to do inverse tan and then 1 over 0.324. Do you remember doing that? Okay, 1 over 0.324. So one more time, I'm in radian mode for this bottom section, then the rest of the day will be back in degree mode. Not sure yet. 1 over 0.324. Yes. So I got 1.257. 1.257. And that would be in radians. Good with that? Okay, one next to it. Do I need to solve for x on number 12? No, x is already solved. All I have to do is what? Type that into the calculator. So inverse cosine, 0.617 gives me x equals 0.906 radians. Good? Alright, switch back into degree mode for me. So in case you haven't noticed the pattern, whenever you have x's, it's going to be radians. Whenever you have thetas, it's going to be in degrees. So if you ever are confused by that, thetas is going to be degrees, x is going to be radians. Okay? So let's look at number 7. We're switching our mode back to degree mode now. Number 7, I would just type that in, so let's do 8 instead. How do I cancel out a secant? Inverse secant first, and then when I type it in, I'll switch it to a cosine. So secant and inverse secant cross out, theta equals, and then I'll have to do inverse cosine of 1 over 1.424. Good on that? So second cosine 1 over 1.424. That comes out to be 45.392 degrees. Oh yeah, that's fine. Okay, now let's remind you how to do 9 and 10. Let's do number 10. How do I undo a cotan? Inverse tan. Okay, but then I don't have a button for that, so I have to inverse tan and flip. Good with that? We already covered that? So inverse tan of 1 over 0.356, I get 70.404 degrees. Now, here's the problem. What x's do they want me to be between? 180 and 270. Is that where 70 is? No. So, remember your little formulas on the unit circle. Okay, I'll redraw it over here in the middle. Your first angle is always going to be here. You're going to just keep it the same. If I want to go to here, I do 180 plus or minus the angle. Minus the angle. Then down here, I do 180 plus the angle. Then if I want to go to here, I do 360 minus the angle. So if I want to be between 180 and 270, 180 is here, 270 is here, then I want to do that guy in the middle. So I would want to be in this section because that's 180, that's 270. So then you just type that into your calculator. So it would be 180 plus 70.404. And I'd get 250.404. And is that between 180 and 270? Then you know you did it right. Okay? So your theta would be 250.404. Good? Okay, so you are going to, today, after your notes, you're going to finish these last two word problems. Okay, we're going to do some more examples of the word problems, though, today. And then when we're done, you're just going to finish up this homework that you've already hopefully done the front of and turn it in. Okay? So, take a look at your first word problem. So it says, a ship is passing a lighthouse. At its closest point to the lighthouse, radar determines the ship is 2,400 meters from the lighthouse. Okay, the ship continues on its path. The next measurement is 2,650 from the lighthouse. So, here's the lighthouse. We'll say it's right here. Here's the ship. Pretend that's the ship. Okay, it's passing the lighthouse. When it's the closest is when it's right in front. So this is the closest the ship can be. How far away was it when it was the closest that it can be? The closest was 2,400. Okay? Then the ship, driving along. Okay, then it says it continues on its path, and the next measurement is 2,650. If that's how far it is from the lighthouse, should I put it here? No, the distance from the lighthouse would be here. So, put your 2,650 as the hypotenuse. 2,650. Then it says, how far did the ship travel? Well, that would be this side here. I'm going to call it A. Now remember, angles get capital letters, sides get lowercase letters. We talked about that yesterday. Do I do trig or Pythagorean theorem? Pythagorean theorem. So I'll do a squared plus 2,400 squared equals 2,650 squared. So we'll do a squared plus 2,400 squared is 576,000. 2,650 squared gives me. Yup. What do I do from there with those two numbers if they're on opposite sides? Subtract that number across. So I'll minus the 576, 1, 2, 3, 4 zeros. Okay, I got a squared equals 1262500. Then what's my last step? Square root both sides. And then, surely y'all know this by now, but if you type in the square root and you don't want to retype that, just push enter on the number and it'll like copy it in there for you. Okay? So I got 1123.610. That's how long this side is. 1123.610. And that would be measured in meters. Okay, part B. A man working in the lighthouse is watching the ship. How many degrees has his line of sight changed as he watches the ship pass by? So you have a dude literally in the lighthouse just watching the ship, and you want to know how far he turned. Do I want this angle or this angle? Side or top? Top. This is where the dude is. Then this is his line of sight. We'll call it theta. Now, if this is side A, what should I label this corner? Big A. Okay, if you forgot that, it doesn't matter. Okay, but they should always be across from each other. So this is vertex A if it's across from side A. Now, when I do my trig, I want to pick the easiest numbers possible. So if this side is 1,123.610, and these are both whole numbers, I'm probably going to pick these two, right? Because then I can avoid all the fractions. So if I want this side and this side, do I want so, ka, or toa? Okay, ka is correct. What's the 2,400? This is the adjacent. What's this one? The hypotenuse. And then A is opposite, but I'm trying not to use that because it's not a pretty number. So I would say for my equation, cosine theta equals adjacent, which is 2,400, over hypotenuse, which is 2650. And then how do I cancel out the theta to know how far theta is? Yeah, cosine -1, which is inverse cosine. If I put it on the left, I have to put it on the right as well. And then you're just typing that into your calculator. So second cosine, 2400 divided by 2650. Okay, it tells me he turned his head 25.0876 degrees. That's how far he turned his head. 25.0876. What's that going to round to? 088 degrees. Make sense? Now, yesterday we were solving the triangle, so you would have not only had to find angle A, but you would have had to find this one as well. Do you remember how to do that? What do they all add up to? 180. So you do 180 minus the 25 minus the 90, whatever's left over would have gone here. They don't ask you for it, but you should remember that from yesterday. Okay? All right, turn the page. 2 more left. Ooh. Okay, Penny stands 12 feet from a statue. The angle of elevation from eye level to the top of the statue is 30 degrees. The angle of depression to the base of the structure is 15 degrees. How tall is the statue? Okay, here's Penny. Okay.